All right then, so let's get started. So in the last class, we were working on this problem that is to sort a given list of names. And initially, we have the first version of the solution in which we were storing the names in a 2D array. Like the data structure that we were using is there on line number 60, which got commented out. So there are two problems with this data structure. That is the size, the length of the array is fixed. So if the length of the array is 20, then you can store a maximum of 20 names, not beyond that. The second problem is, if the row length is, let's say, 15, then you will not be able to store names whose length is beyond 15. So we tried to solve one of the problems here, that is at least we should permit the names to be of arbitrary length. So there is no limit on the size of each name. And in order to facilitate that, we switched over from a 2D array to an array of character pointers. So you can see on line number 60, it is an array of character pointer. Names is an array of character pointers. So let's see. So if you see names, it is allocated memory on the stack. It's an array of character pointers. So we have 0, 0th element, first element, so on and so forth. Jth element, like that. And let's see the base address of this array. Let's say if it is equal to 1000, then the names, the names variable will contain 1000. The array names, it contains the base address of this array. Thousand, okay. And we are passing to read names function this value 1000. That is the base address of this array. Since it has the base address, it can now kind of modify each of the elements of this array without any problem. Right? And if you see the read names function, so the important idea here is read names function, it uses a temporary buffer called as current underscore name. So what happens is in the read names function, there is a buffer called as current underscore name. Its length is of 100 bytes. And what happens is we have what is called as a keyboard buffer, which when we type characters, it goes to keyboard buffer. KB stands for keyboard. So on line number 14, when we enter when the scanf function, what is 1000 other? Current underscore name, it is Mag's name. This is 1000. Yeah, that's true. Let me use, yeah, what are you saying, Adarva? Did I say anything wrong? Okay. Yeah. So its length is 1000. Yeah, yeah. Its length is 1000. Yeah. So maybe in order to make differentiate between this 1000 and this 1000, let me say the base address of this array is 100. So the base address of this array is 100. So 100 gets passed as parameter here, and whatever you type in the keyboard, so it gets transferred into this current underscore buffer, current underscore name buffer, because of the scanf state. And what we do is let's say you type in Venu followed by null character. We compute the length of this whole string, that is 5 bytes are required to store this whole string. So we allocate that much amount of memory using malloc. Okay. So, and you store, this is coming from uh, this is coming from the heap, the yellow thing, it is coming from heap. Right. uh, so, and then it keeps going. Every time we go into the loop, we keep doing this. We keep we allocate one more array depending upon the name that is entered, and the base address of it, we store it here. This is how the read name function works. And after this, we call the sort names function. In the sort names function, remember we are doing a bubble sort. So we compare two consecutive elements and see if there is any necessity to swap them. So this is 1. So this is j plus 1. So we compare these two strings and check if it is necessary, if there is any necessity to swap them. Like for example, you may have something like here Banu, and you can have assume that null character is there at the end, uh, and then we have Arav here. So you compare these two names, and Arav comes earlier than Banu in the lexicographic order. So we want to swap them. The interesting thing I would like you to pay attention here. First of all, let's use this thing yellow to indicate no, this is coming from the heap. And so let's assume that the base address of this character, the base address of this character, this is 2000. The base address of this character string is 2000. The base address of this string is 3000. And let's assume that no, the address of this the jth element is 500. So a pointer is usually allocated 8 bytes if I am right. So because of that, the address of the next element is 508. So 500, 501, 502, all these addresses they contain, they correspond to names of j. And no, so this is 2000 is present here, and 3000 is present here. Are you all with me here so far? So in a string compare function, when we want to compare these two strings, we will be passing the base addresses of these two strings. So we will pass 2000 here, and we will pass 3000 here, and string compare will know the string starting at address 2000 and the string starting at 3000, and it compares these two strings. But when we want to swap these two names, so the way we do the swap is we just change the pointers so that this will point to this and this will point to this. That is our swap operation. The way we do the swap is just by changing pointers. So in order to do this swap, what do we do? So here we are passing address of names. So we pass 500 here and we pass the address of next element, which is 508. And then so here we have 500 and we have 500. And str1 contains 500 and str2 contains 500. So now here I have a question for you. So if str1, this is str1, if it contains 500, if str1, this is str1, it contains 500, and when we apply star str1, then what happens is the value that we get is you go to the memory location 500, and what is present at the memory location, it is 2000. So the value of star str1 is 2000. Star str1 is equal to 2000. And if we apply star str1, then what will happen is you go to the memory location 2000, and what is present at the memory location 2000 is the character B that is present. So the same story applies even for str2. So str2, we are passing 508, and when we say star str2, then what happens is we have 500 here, and we will have 3000. Yeah, so we will have at 5000 at the memory address 508, we have 3000. I made a small mistake here. So you go to the memory location 508, that is 3000 is present here, and when we do star str2, then we go to the memory location 3000, and what is present is C. So now here, when we let's see how this swap happens. So what is star str1? Star str1 is 2000 because str1 contains 500. You go to that address and get that value. So this is equal to 2000. And this 2000, we are storing it in the temporary buffer, in the buffer temp. In a variable temp, we are storing this 2000 through this assignment operation. The next thing we are doing is we are copying star str2 to str1. So what it means is the 2000 here, it will be knocked off, and we will write 3000 because star str2 is 3000 and star str1 refers to this particular memory location. So you go and copy this. So this copy is happening here. And finally, when we say temp is equal to star str2, so temp contains 2000. So this gets knocked off and we get 2000. So and this 2000 is coming from the temp. So at the end of this operation, so there is a swap happening because this element is pointing to this and this element is pointing to this string. So in the memory, in the heap, Banu and Arav, they are where they are, but all we are changing is we are changing the pointers. Okay, fingers, we are just changing the fingers. And that's what we are doing here. And that's all. This is what this is how the whole program works. The whole program works. And do you have any questions here in this regard? You're all good here? You understood completely what is going on? Great. So now let's move on to the next program. If you're all doing good here, so then we will move on to the next program. So let's clear the screen. So the next problem that we would like to solve is this. That is, we would like to see that we will be able to handle arbitrary number of names. That is, we should be able to handle, if there are 20 names, we should be able to handle 20 names. So no matter how many names are there, we should be able to handle. So Anjali has this question. Yeah, can. You mean the loop from 62 to 69, Anjali? Well, we have seen this before, but I'll quickly review. Uh, so yeah, so you tell me. So in the we reviewed it in the context of no integers, and so let's say if the numbers are 20, 30, 40, no, 50. Let me use 15. So the overall goal is in the bubble sort is to know you take the whole list and you bubble up the largest number. So at the end of iteration, at the end of outer iteration, so here I is equal to 0 and no, it is less than or equal to 4. So you go from 0, now we are considering the whole list. And when we look at when number of names is equal to 4, so 4 minus 1 minus I is equal to 0, so j less than 4. So we are considering the inner loop is considering the whole list. And in the inner loop, what we do is we compare two adjacent elements and so from so 20 is less than 50, so it becomes 20, 50, 15, 40. You compare 15 and 50 and 15. So 15 will come here, 50 will go here, 40 will be here, and then you compare 50 and 40. This is what you get. Okay. So once you get this thing, once you bubble up 50 in iteration I is equal to 0, you bubble up the largest element. So now when I is equal to 1 in the next iteration, so the inner for loop, if you see, when I is equal to 1, the inner loop goes from j is equal to z to 0 to j less than 3. That is, it only considers the elements, the first three elements. It doesn't consider the last element. So it applies the same bubbling process here. Okay, so it is like you are keeping this aside because you already figured out its position. So you keep it aside. Okay, so that's the idea. So now let's go to the, yeah, so yeah, we do read names. So we have a, yeah, so we want to uh, we want to modify our program so that we can handle arbitrary number of names. So towards that, we would like to allocate memory for the character pointer array. Like we have seen in the earlier program name sort, in the previous we were using an array of character pointers, but that array of character pointers which you see on line number 77, it's a static memory. Static in the sense it is allocated memory once, it's not dynamic memory. But now we want to deal with an array of character pointers, and the base address and so the base address. So but where will we allocate memory for this? So if you see this read names function, so let me do one thing. uh, yeah, let's use these names only. So here, this names variable, what we would like to have is, after we call the read names function, and when we are out of it, the names variable, it should contain the base address of the character pointer array. This is 0, 1, 2, so on and so forth. So let's say if this base address is equal to 100, or no, then the names should contain, the variable names should contain the variable names, it should contain, let's say, the memory location associated with names. So let me use here. So this is a memory location associated with names. This should contain 100. All right. And this character pointer array, it is allocated memory from the heap, because that's what you will see how we will do it. So now I have a question for you. So the type for names, it's a pointer to a pointer. So the type of this element, the type of each element is a pointer to a character. So the type of this element, the type of this element, the type of this element. So the type of each of these elements, it's a pointer to a character. And since name is pointing to like for example, the first element of this array, which is a character pointer, the type of names is pointer to char star star. It's a pointer to a character pointer. So going by that spirit, what is the type signature for the read names function? What is the type signature for the read names function? What is the type signature for the read names function? Yeah. So it's a pointer to a pointer to a pointer, character pointer. So what happens is, if you go see this read names function, it is bit no, it looks clumsy, but I want you to understand it clearly. So you have the PTR names. You have the PTR names. This is a variable, and it is the type of this is it's a pointer to a character pointer to a character pointer to a pointer. Okay, char star star. Okay, so it's a pointer to a pointer to a pointer to character. So that's the right way to put it. So anyway, don't follow my words. See what is happening here. So if you see, each of these things, they point to an array of characters. So what is the type of this element? What is the type of this element here? The type of this element is a character. So, and this element contains the address of the character. Because of that, it is a character pointer to a character. So this is a pointer to a character. So pointer to character, its type, because it is pointing to a character. And if you see this one, this is a pointer to, I will just put, it's a pointer to a character. And if you look at this one, its type is pointer to pointer to uh, pointer to character. So, and the number of times you see this PTR2, that many stars it should be there. All right. Class learning. Uh, so yeah, so now let's say PTR names. So now when we are passing address of names as parameter, in this function read names. So what happens is the address of names, let's say this names, the address of names is something like, no, this is 500, then this 500 will be present here. So here 500 will be present here. The address of names is present here. And on line number 16, you can see that we are using malloc to create an array of character pointers. We are creating an array of character pointers on line number 16. Right? So when we do an malloc, an array of character pointers, malloc gives us some address, and that address is assigned names. This names is, let me use a different thing for this. This names is a different names, okay, names underscore L. Okay, so, and bear with me for a moment. I want to disambiguate something. Great. So now what happens is we are allocating an array of character pointers, the amount required to store an array of character pointers by making a call to malloc. And no, that address, malloc gives an address. That address we are assigning it to star PTR names. Let's say malloc returns 100 because 100 is the base address of this array. That's what we are assuming. So let's say it returns 100. So that 100 will be using this particular operation, star PTR names is equal to 100. Then what happens is, this gets updated to 100. This gets updated to 100. Are you all with me here so far? Questions? Yes, no? Unit list size is the number of, because we don't know the number of names to start with, we assume let's start with an initial list size of 20. So using the while loop on line number 19, we keep reading the names. And on line 24, you can see whenever we read a name, we increment it by 1. And this is the code is very similar to what we did before. But the only catch here is on line number 25, you can see that when the number of names reaches the current max size, we increase the list size, and then we do what is called as a realloc. We make a call to realloc. What realloc does is it tries to expand. Let's say what realloc does here, if you see, what realloc does is it tries to expand the memory of this. So earlier, let's say the size of this list is 20. We have incremented its size to by adding 20 more, and we make a call to realloc. So what happens is realloc tries to expand the memory that is allocated, the chunk of memory that is allocated to us, so that this memory can be used to store. Are you with me? One important thing is realloc. So if this is your whole heap, if this is your whole heap, so initially, let's say the memory for this is allocated somewhere here, somewhere in the heap, and later on, so so what realloc tries to do is it tries to expand the memory for it locally without no at the same position where that previous chunk of memory is. But if it is not able to expand because no some other data, that chunk of memory is allocated to something else, so it will copy it to a new, the whole thing to a new place, and where that much amount of memory is available. So because of that, when we do a realloc, there could be a change in the memory chunk that we already have. Because of that, we have to reuse that address again. The contents wouldn't change, but the address may change. So because of that, we have to say names underscore L is equal to realloc. So this is how the whole program works. So you keep you keep increasing the amount of memory that is allocated. So initially you start with a list of size 20, and then you increase it to a list of size 40, and then you increase it to a list of size 60, so on and so forth. And you use in order to expand your memory, you use the realloc function. That's all. And this whole now the array, everything is present in the heap. So the memory that is allocated stays there unless we explicitly free it. Any questions here? Does it make sense? Yes, no, maybe. Line number 28. So let me do this. If we go up a bit, yeah. So you try to uh, increase the, let's say, so far you have allocated 100, 100 you have memory for 100 names, and then you want to increase the memory to 120 using realloc. But unfortunately, realloc is not able to get that much amount of memory for you. So what it will do in that case is it will return a null value. Okay, in which case we will get no unable to, we will say uh, that we got into a trouble. Realloc is not successful, and no, then we will come out of the loop. Okay, so all right. So I hope you're all with me here. Anjali, does it make sense to you? Arnav, Arshini, Aryan, other. Line number 27. So what we are doing is on line number 27, we are saying, no, I already got this much amount of memory. No, and the first parameter here, let's take a look at, let's go back and if you see man realloc, let's The realloc function, if you read here, let's clear this here. The realloc function changes the size of the memory block pointed to by pointer to size bytes. The contents will be unchanged in the range from the start of the region up to the minimum of the old and new sizes. If the new size is larger than the old size, then the added memory will not be initialized. So that's all. So yeah. So that's what realloc is trying to do. Realloc is trying to expand the amount of memory that is given to us. So here, so names underscore L points to a chunk of memory from the heap that is already allocated to us, and we want to expand its size, and how much we want to expand is given by the second parameter. And realloc expands that memory to that extent. Okay, does it make sense, Nikhil? Are you all good? All 86 of you? Anvit? No, names underscore L doesn't increase. Realloc increases, Nikhil, not names underscore L. Names underscore L, it's just the name of a variable. Realloc increases. Earlier, let's say names underscore L, where plus equal to. Oh, that is the earlier, let's say the current size is 100, and if we want to increment it by 20, so we will make it to 120. So let's say the current size is 100, we want to make it to 120, so we add 20 to it, 120. Yeah, Geet, so you should know the next week, etc. You should spend time try to understand these things, because in the data structures course you will be using these things a lot. But it's not very difficult. No? Like, what we do is using malloc, you get a chunk of memory. In realloc, you try to expand it. Yeah, after in the realloc, after the comma, it indicates the total size. Now the total size of the array, total memory required by the array. Because let's say current max size is the array, it has 120 elements, but the number of bytes required would be 120 into size of each element. Textbook gets everything is there in the textbook. I don't know how many of you are reading the textbook. Everything is there in the textbook. Good. So now let's go to the next program in this series. So this is a program in which so this is a program. So remember the sort function the sort command that we have seen couple of classes back, or in the last, maybe couple of classes back. It's a command line function. That is, it takes arguments on the command line. So now we want to change our program. So we want to modify our program so that it can also be like that. So here, let's say the last version of the program that we have is this. And what it does is, if you see, so let me remove So you can see cat names dot text, and then we say dot a dot out names dot text. So when we do that, what happens is the sorted names are present in the file sort uh, in names.text.sorted. It is present in this file. So we are reading. So the command that we gave is the a dot out followed by the file which contains the list of names. So if you see here in this program, so arg v of 1, so if the number of arguments is less than or equal to 1, then that means no only a dot out is there, but no file is there. Then there is a problem. We need a file to sort, in which case we should print the output to the user saying no sort usage is sort followed by file name. So let's try this out. And if I do, let's say a dot out, it just says uh, its usage is you have to give the file the command followed by file name. It complains. But on the contrary, let's say if it has a file name is given, in which case the number of arguments will be greater than or equal to 2. So we go to line 94 and arg v of 1, it will contain a pointer to the second argument. So if we have something like this, so if we have something like dot a dot out names dot text, so arg v of 0 and arg v of 1 contains a pointer to this names.txt command line argument. So on line number 24, we are reading this file in a in a read-only mode, and if no such file exists, the file pointer will be equal to null. In which case, we print saying that file doesn't exist. So let's see if we do something like so there is no file called names2.txt, and when I press that, it says no file doesn't exist. And then on line 103, you will see that you you are creating a new string with by concatenating dot sorted to names.txt. So output for fname on line number 104. After that line gets executed, output fname contains the file name and with dot sorted added to it. Okay, and then again on line number 106, you open that file in a write mode. In a write mode. And on line number 108, you are calling the read names function with by passing the fp as a parameter, the file pointer fp as a parameter. So if you go look at the read names function, this read names function is exactly the same as before, except that no, the fscanf, instead of using scanf, we use fscanf fp. That's what we are doing here. All right. So similarly, if you go to, and then sort doesn't, it's not going to change. You read the names to your file and sort doesn't change. It will be the same. And yeah, but then if you look at the print names, the print names function, it takes the file pointer, and instead of printing the names, the sorted names onto the screen, it uses fprintf to print it onto the into the file. So fp is the file pointer, and whatever fp points to that file, the names will be printed. So if you go see here, so after read names, So you have, what do we have? So you have read names, we have sort names, and then we have print names. And to the print names, we are passing FP out as the third parameter. So, so what happens is the sorted names are written to the file to which FP out is pointing to. And FP out is pointing to the file names.txt.sorted. So this is how the whole thing comes together. Does this make sense? Does this program make sense? Do you see what we are doing? Like how we are using command line arguments, how we are using files, how we are using pointers, everything, all ideas are coming together and in this program. Are you with me? Yes, no? I see complete silence. Where are you all awake? Yes, it concatenates two strings. It concatenates two strings. Ishwara Rohan. So, what's up? Durga. Are you able to understand this program? Did anyone of you try to write any programs using no files, command line arguments? Did you try? You should all take stringcat is very simple. So you should just read man. So Ketu, I don't want you want to explain. I want you to read the man page for stringcat. Man strcat. Read it and then you tell me what it is. Okay. All right then. So let's stop today's lecture here, and we will catch up again in the next